Awesome. Hi, everyone. Hello. Thank you so much for joining, and welcome to the Open Telemetry in User SIG latest edition of OTel in practice. My name is Sophia, and this is Victoria. She'll be leading the Q&A later today, and we're excited for everyone to join. And oh, sorry, Victoria, you want to say something?
Yeah. So
I'm sorry.
not much. Sophia. Sophia already introduced me. Hi everyone. I'm Victoria Anduka. Uh, yeah, and I'm excited to host this hotel and practice session. Really looking forward to it as much as everyone else. So yeah, let's get into it.
Perfect, perfect. Yes, and just want to remind everyone to tell a friend and remember that these videos will be available on our YouTube channel, which is OTel
Mhm.
Official, or on the OTel LinkedIn page. So today we have an awesome session with Jose Sayez Gomez Sayez, sorry, and he'll show us how to roll up our sleeves and get our hands dirty with manual instrumentation to produce cleaner telemetry. Um, and hello, welcome, Jose.
Hello.
We're
Hi,
here.
Sophia. Hi, Victoria. It's great being here. Thanks for having me.
So
Yes, we're
you're
so happy
welcome.
to have you.
Mhm.
um, so you want to do a quick introduction of yourself, and then maybe we'll jump into it after a quick disclaimer.
Sure, I can do that. So my name is Jose. You pronounced it very well. That's not that typical, so thank you for that. Um,
Mhm.
I work as a product lead at VictoriaMetrics Cloud, and I've been around in observability for mostly now like 2 or 3 years, maybe a bit more. Time goes fast. In many projects. So now for me it's a complete honor to be here really with you folks that do this awesome job and on all the community. So yeah, I'm very happy to be here.
Awesome. Thank you. Awesome introduction. I couldn't have done better. Um, Also, if anyone is interested, please post your questions to Jose's, you know, talk here in chat, and then we'll go over them after the presentation. And yeah, let's just get started. Thank you.
Okay, thank you very much. All right, so I will then start with my slides there. Awesome. Thank you. So yeah, let's talk about how to instrument the code. Let me set my timer so I don't get. Yeah, but here we are, and let's start to talk about manual instrumentation, and I will deep dive on why I believe this is important and why some concepts are needed, especially because we all talk about serial code instrumentation. That's super cool, but it can be difficult to start. So maybe this talk would help you to get a start. Right? So let's go for it. I just presented myself, so not going to deep dive too much into that, just to say that apart from work and programming in C++, which is my background, maybe it sounds like old-fashioned, but I can tell you that it's everywhere, so it's a great language to learn. And I also like to play metal and listen to it. So we can discuss about that later or in this social media if you like. And when I'm not doing that, I like yeah, to play in my simulator. Okay, let's get started. When you talk about OpenTelemetry, then it's about observability. And if you think about observability, you are thinking about, oh, cool dashboards or great databases that are super performant, right? Well, you know, OpenTelemetry is not really about those. OpenTelemetry is actually what generates the signals, right? Is a collection of, is a standard, and it provides a collection of tools, APIs, SDKs to help all this communication and all this signal generation, so you can instrument your code and start observing what's going on when you're running in production, right? So that's why we're here to talk about instrumentation. And as I was telling at the beginning, um, instrumentation and OpenTelemetry, normally people think as synonyms of zero code, right? And this can be, it's awesome because it's effortless, and you do it by deploying some agents that can do some stuff for you, so you don't need to do it. It has some mechanisms, so I'm just going to enumerate them. But for example, if you work with Python, that would use monkey patching to change the behavior of your functions when they run in productions, or bytecode manipulation if you're in Java, or eBPF. What eBPF does is like it installs some programs in the kernel, right? For example, when you're gonna send HTTP message or a networking message or things like this, you can install this small kernel program that will say, hey, now I'm going to send a message, so let's create a metric so I can monitor later, right? So you don't need to touch your code, you can do it at kernel level. So my point here is that there are many mechanisms in this great and big standard or project, better said, and these are great. They are great for understanding your libraries. You can just by configuration really activate them. And when you want to understand the edges, for example, hey, I have my code, I am using this API to talk with this database. I don't know if the problem is in my code or if it's in this API. In this case, it's amazing because you get all this information out of the box. And of course, there is a but, right? Well, it can be hard to control the data, right? If you think about all this magic, it can easily start generating a lot of signals that then you will need to store, or your platform needs to manage. And it means performance losses or cost increases, right? And at the end of the day, what you really want to know is how your code is performing, right? On top of that, as I said, and I said that for a reason, my background is in C++. In this language, you cannot just press a button and magical things will happen. You need to do them by yourself. So for all of these reasons, and that I said, at the end of the day, if you want to understand what's going on with your code, you need to do something about it. You really need to generate your signals. Sooner or later, you will need to do that. But the problem is, when you try to do it, then there is a barrier. You need to learn. Actually, there was this very special interest group did a survey not that long ago asking, hey, what do we need to improve in OpenTelemetry? And people were giving the feedback like, we would like more examples. Why? Because I can tell you, I agree, or I believe the standard is awesome and the documentation is great. But we are humans, and sometimes we just need an example to get going and learn, right? Also, I've earned some, not a lot, but some karma points helping people to in Reddit to showing how to instrument code with examples. My point with this is there is a barrier to be solved. So this is why I want to talk about this today and why we are doing this session, right? OpenTelemetry has metric logs and traces. So let's get, as I promised at the beginning, let's get our hands dirty by and let's start with how to instrument metrics, right? This is pretty simple bit of code. At the end of the day, you have your function and it may go wrong and you have a catch to get your error and you want to monitor. So this is a general case in which you just want to have one counter, so to say, and put a ++ on it and get on with your life, correct? This is what we want to achieve, actually. And then you start reading the documentation, I was saying, and you start, okay, I have an API. Okay, makes sense. And I have measurement, I have instruments, I have meters, I have meter providers. I said, okay, then you start reading, you continue, and then you see the SDK. And the SDK, oh, okay, what is the SDK? What is the API? Like in this, like you may know these concepts, but in this context, it can, then you have a reader and exporter, it can get tricky, right? So what I want to explain right now is these two big groups and why they are important. Because by the minute we start knowing these couple of concepts, I promise it's not much, then we will start using them and it will be super easy to generate code. And I will also explain how OpenTelemetry help us to generate clean code or clean observability, right? You're lucky because we don't have a lot of time. I have other slides. Actually, we can if anybody is interested, you can write and I will be sharing, we can share some repos. I really recommend people to go to the OpenTelemetry.io document and the documentation because there you have maintained examples. Here, I'm just going to explain the concepts you need to understand them, which is, I guess, the barrier that we can jump. So you're lucky about that. I'm not going to explain all of this. I did that in the past. There are other talks about this, but we don't need to go over that. What I really want to explain is these concepts, right? So let's start. What do we want? We want to add a sample, right? A measurement. I observe something. Hey, I have an error, and I want to add this. So the first, how to say that? The first concept here is a measurement, right? Yeah, and we are now speaking the OpenTelemetry language. So I will have a measurement, and I want to add it to a metric, right? Like the number of errors, my number of errors, right? Or Jose errors in my program, right? So I will add this measurement into the instrument. The instrument is the name of the metric or the metric itself, and the measurement is the sample. And how do I create this in my code? By calling something called a meter that is given by an interface. So in this meter, I will generate or create at the beginning of my program these metrics that I will use, these instruments, sorry, that I will be adding samples or measurements later. That's it. This is the definition of the API. You don't need to learn more. Actually, just a bit, if you stick with me. Because what happens to this metric? Right, we added it. Okay, I have this thing provided to me by the library. It's called an instrument. I know how to generate it with this meter thing. But where does it go? It goes to the SDK world, and this is into the aggregation store. And the aggregation store is nothing but, well, I mean, you can see, right? It's just a small cache that I will that will store these in memory these values. And then I can define in this SDK, hey, read them every, I don't know, 10 seconds when the cache is full. You can set and configure different things and export them in the OpenTelemetry format to my backend, to my collector, something else. And now, yes, we're done. So we have this differentiation. And why is this differentiation important? Because in the top part, the API, is where I pollute my code, so to say, right? Is the dirty part. I need to put this everywhere in my code. But then the SDK, I can put it somewhere else, and it's just hidden, right, from the rest of the code, and it's easy to change. And this is the important and the cool part, because I am telling you, oh, this is OpenTelemetry. But you know, normally in production and large enterprises, we don't like to change our code, right? Nobody does. Like it's a huge effort to do across many microservices or whatever. Just imagine tomorrow we decide, you know, we decided Prometheus format is more important because someone read an article in Reddit, whatever. Then the only thing you need to do, and this is the important bit here about having clean code. I can define another reader. I can define another exporter because it's supported in the OpenTelemetry ecosystem, in this case, Prometheus. And Prometheus will come back and read. So with just creating a couple of functions, I can just interchange them and provide two versions of my code. And I don't need to touch a single line of code of the whole let's say, a metrics system across, or functions and goals across my code. So this is super powerful. And okay, so we learned about C++, right? It says C++, but I bet nobody here listening, or not a lot, are programming in C++. Maybe you do other programs. This is a standard for all languages. So now we are experts in every language with OpenTelemetry. Now, with knowing these concepts, I can go to the documentation, or of course use some LLM, and help me to do this, because now I know how to make it. And this is the important bit. So hopefully with this, you will be able to start instrumenting your code in a clean way. I will be showing how this looks in case, for example, something I learned in observability is that we all have very different backgrounds, right? So just imagine, hey, I am very used to Prometheus, but not to OpenTelemetry, or the other way around. I will just show a small demo on how this looks like in reality. In this demo, you can find it in this link, but as I said, right, you can go to the OpenTelemetry official documentation, and you will find it there, right? But I will have this client sending to a server some requests per second. Actually, I can tell you how many did I say. Okay, 10 requests per second this time, and some get, posts, deletes. I am sending those with HTTP. And then I am collecting all these signals with an OpenTelemetry collector. Then I have them in a backend. It doesn't really matter because this is a standard, as I said. And then you can visualize them in like Perses or Grafana or wherever you like. So this is the setup I'm going to show across these 30 minutes that we will be around. And as you can see, of course, I have some slides in case everything fails. But here I have this live. And as you can see, I have created with just 4 metrics an APM. So I have instrumented my code, as I said, my client, with 4 metrics. And with this, I can build a dashboard to understand how good or bad I'm doing. I have this success ratio. How do you do it? This is my instrument, right? I created one, okay, this load generator, I called it Hermes long time ago. And I just created one metric, and I put labels per request ID and this other one. So these 2 instruments I created in my code, like how many requests I sent and how many responses I received that went okay. So now I can have this KPI for my managers and things like this, right? And then here is actually a breakdown on this. These are actually histograms. So histograms may be a concept more that you may think, if you come from Prometheus, like it's more from there. Here, of course, there is this concept as well. So I created a couple of metrics here, like the count and the sum of them. With this, you can see your latencies, and I can, because I have different labels, I can see them per kind of request. So pretty easily, with just 4 metrics, now I have a dashboard and I can check how my dummy application is doing. And I think it's pretty powerful, actually. So, okay, we are expert in metrics. That's super fine. But we all know what we love. What we love is logging. Why logging? If you think about it, logging is what we do our first words as programmers, right? And our first words as programmers is actually observability, because we say hello world. So we send a message somewhere, and then we check that our program is running well. If we don't see the hello world, then we don't know it's running. So actually, that's observability from day one. How how logging works in when you work with OpenTelemetry normally is like this, right? Like I showed you in the example earlier. You have your application, you are sending your signals, you have a collector, and then you have them into a database. But nobody likes that, right? What we like is to put it into the console. Even us that work and do a lot of advocacy and observability, we all say, yeah, I will put this into the console and I will check later, right? Well, if you allow me to try to convince you, if you use this setup, you will be able to add Kubernetes attributes. For example, I have this log that is coming from this pod, right? My code doesn't really know the pod. It doesn't know the container. It doesn't know the cluster that is running on, right? It just knows the software itself. I can also do batching, filtering, like some transformations, and then I can help with all of this. And I will elaborate a bit later. I can help my database to correlate on my UIs and systems. So if you allow me to convince you with this, yeah, I don't know, maybe you will not really want to do that. At the end of the day, we will all use this. Why I'm doing all this joke? Because another good thing, because I'm trying to talk about manual instrumentation, but from a real perspective. And in reality, if you start sending your logs to the console, we are in Linux, console, everything is a file, right? The OpenTelemetry collector has a great receiver, file log receiver, has many receivers, that can take this, can read from your console for every microservice, for example, and then you can do some parts of this. If you don't do it manually, in your code, it's not the same, but it can do some parts of it, and it will really help you. So I can show you how it looks. Actually, here, what I have is a set of logs, because the server, I programmed it in Golang, and I am not an expert in Golang, so I was throwing them to the console, right? And here, this is kind of old, I believe. I hope it doesn't refresh. If it refreshes, I will take a look again. But as you can see, my point is, I have this log line, okay? I was throwing to the console only this line, as you can see. Request received on this URI with the method delete. I mean, it's pretty cool log. It will help me in the end, right? It's an informational log. What the OpenTelemetry collector is doing for me, if I don't want to use the API, the library, it's already adding this is a configuration I did, but it's adding the container image, the container tag, the cluster ID, the container name. And why? Because this is OpenTelemetry, is a standard, and all your backends and UIs, when they adopt this standard, they will know about this. So they will help you to correlate or do other things. Of course, it's not like I have a lot of time to deep dive into everything. Yeah, totally. And but you have all this information, and the only thing I wrote is this line. So it's kind of, but by the way, I really like to see that, because it always helps me while debugging in production. You can also see, for example, the restart counts, right? There are all these myriad of Kubernetes events and information that it's included in the standard. Okay, and by the way, you can also add this into your dashboard and do cool things with that. In this case, I am generating some sort of metrics from these logs, right? But they are logs, I promise. Okay. Okay, so we can still do this. We can still do this. This collection of the console. But if you allow me, I just explained to you the concept you need to know in metrics. In logging is the same. It's the same sort of API and SDK differentiation. And this is how it looks. And actually in C++, I would really advocate for this, because it's one of these languages that you really need to cook things from the beginning, right? You need all the ingredients, you need to do everything. And here you have a well-defined library for you. This means that I don't need to create and invent myself way of making debug versus info versus warning, or choose if I want this standard or the other. This is a standard I can use for all signals. So it's actually going to be pretty helpful. And as you can see, pretty easy, right? you can actually add more or enrich more information. And this will help. Like this is more of a cliffhanger. I will talk about now about traces, but you can also in this log tell, this log is part of this request that I am managing. So at the end of the day, I will be able to correlate, and I know this only in my code. So I hope this last argument will really convince you to start using these libraries or using them more, maybe for very important logs. Of course, console logs are very important. Last thing, why? Like I was showing how useful and cool this was, but now if I show you this, right? If you are watching this afterwards, maybe you can stop the video and check. If I ask you what this is, it can be very difficult to know, right? What am I showing here? What I am showing, maybe not the best colors, is a hello world message again. And why am I telling you this? Because these things can get expensive, right? At the end of the day, we are talking about some strings. We all love to produce data because then we can save it for a rainy day. This is something like it comes with some cost, right? But those are more into the optimization world. But yeah, actually, I would say that we like to log a lot when we really want to trace. And this is a hill I can fight on. So I will make a super quick intro on traces, because what I hear normally is that folks may have some misconceptions. For example, from the world I come from, trace is looked as a very low-level debug log, and that's not really it in this context, right? So I am playing all the time in my talks this game. I think this may be the last one I do it, because I've been doing it like for a couple of years, but I really like the example. So let's play this game together. Let's try to think what some images I'm going to show about dogs, what they are doing. So in this case, I'm showing a dog. What is he doing? They could be sitting, they could be running. I think this one can be laying down, right? We can agree on that. On this one, we could argue that looks like they're standing. And this one, the poor thing, is kind of sad, right? It's sad because you're not using traces. And you are lacking context. Why all this joke? Because the point about traces is that they give us the context. With the context, we can know everything, right? And this is why it's important, especially in microservice and the cloud world. This is getting old, I know, but it's still important for some folks, right? As I said, we have different levels of understanding or our experiences go in different places, right? So traces will help us to get the context on very rich and complex systems. And what I can do is, if I start aggregating all the signals under the same trace identifier, and we will call that a trace, then I will be able to see it in a nice way. And then I can aggregate and say, okay, all these signals come from the same request. And I can see with context what happened. I know this is a very, very quick intro or explanation, but hopefully it will help to understand what I'm trying to say. And what is this span, right? As I said, a trace is a collection of spans, and a span represents an operation. So every operation I will be generating a span. And the cool thing, the important thing here is that it represents an operation with time. So you can think of it as a log that has some attributes and a time dimension on it, right? Let's talk about how to use it. Again, I will not show all the code. Actually, I don't have too much time for that. But the concepts are the same. So instead of having this meter provider, I have the tracer provider, right? The same concepts. I have the important bit here. If there is only one concept, I would love people to get home, is this differentiation between API and SDK, and I just need to define them, and start using them. And here is where the exporting happens, and here's where I pollute my code, so to say. Right? But it's the same. It's the same. Here I will have some configuration, like I will process all my spans in this way, or I will buffer them. This is the differentiation that is important. And two important concepts, if I may. It can be tricky to define. Just imagine, I was telling for logging or for logging libraries, I am happy with the OpenTelemetry library because it will help me to define, oh, this is how I put debug logs. This is how I add warning logs, for example, right? What about, hey, I am tracing a request that goes via HTTP. Which fields should I use for it? You know, there's this thing called semantic conventions, and they provide, in the library, a way to call things in your code without you needing to reinvent the wheel anytime. And you have one of them for, I don't know, if you are programming a database, there is an interest group that went together and defined how things should be called in the database. If you are having a function as a service, it goes the same. So, for example, HTTP, what you were seeing, or what I will be showing actually, I am using the primitives of the library, so I don't need to define them myself. So, for example, I have the method, HTTP method, right? Post. I don't need to create, how do I name this in my code? How do I do all of this? And I don't need to argue with my colleagues in the code review, like, oh, you use a snake case, but I like a kebab case, whatever. You don't need to do it because this comes in the standard, it comes in the library. You just need to import it and use it. And that's super useful, super useful. So we will be using them. That's concept number one I want to show before going to the demo. And concept number two is context propagation. I am talking about different microservices talking to each other, and this information needs to travel somehow, right? This is standardized actually in the W3C as headers. So all your libraries will be having it. And in case you need to write them yourself, you can take a look at the specification. And this is super important because as I said, we need to aggregate all these operations all together, so I see them with context. And I understand that maybe what failed at the end of my request is because at the beginning I received some unexpected field that I carried over. Right? If you want to read more about this, we wrote an article, my friend Israel Blancas and myself, on how to put service mesh and OpenTelemetry together for context propagation. So there is another one in the Cloud Native Foundation. But yeah, the Cloud Native Foundation blog is actually great. It has useful information. So about traces, what can I get with traces? I told you, we have time dimension. So because I have time dimension in my logs, I can check the duration of this operation. So here, I am interested in seeing what happens with my GET requests. I created this small section for GET requests. Here, I represent all the logs. And here, I am checking I can see the duration of everything. So if there's an outlier, I can check. And for example, if you want to see how a trace looks like and what can it help me to debug, here I am showing a trace of my script. As you can see, I have here many operations. They all happen. And here I can see which service is producing them. And I am putting them together under the same trace ID. I'm going maybe quite fast, but hopefully it's understandable. And here I have all these myriad of attributes that I added while using my the library. And in this case, if I want to check where my time went, with logs I cannot do that, right? Here I can check that here and here and here I am spending most of the time. In this case, There is a sleep. I know this. I can tell you. We don't need to spend a lot of time, and it's because I have a sleep to calculate the rate, right, and on how many requests per second I send and all of this. But I could be identifying this in production. So this is why this is super important. All right. So the last part that I want to check, and I am a bit late on time, but it will take a couple of minutes, I promise, is about span metrics. I said how to generate metrics, logs, and traces, but I just want to say at the end of this conversation that metrics or logs can be generated out of traces. Traces have a lot of information. So for example, and you can do this super easily. You don't need to even do many things in your code. So for example, you start with traces and you want to see some metrics. Just by adding these 4 parameters, I promise. Actually, you can check it in the demo. You can start generating you don't need to generate these metrics in your code. You can generate them on the fly in the OpenTelemetry collector. How does this look like? Well, here I was sneakily hiding this part, which is exactly the same. Of course, here I have a lot of resolution. This is like the cent of the millisecond, so the shape will be different. But here I am mimicking the same, but without generating the code, but generating the signals in my code, but generating them in the OpenTelemetry collector. So here, as you can see, this is like super standard. This doesn't have any weird name that I invented. It's standard and it's created for me because I have the traces. So it goes for the traces and it starts to create these metrics. So I can mimic the same. I will not get too much into details, but my point is actually I can go to the summary directly and say that, hey, now I'm going to the summary. I can say, hey, what we've seen, right? We've seen that you can easily generate instrument with OpenTelemetry. The important concept here is this decoupling between API and SDK. That the semantic conventions will be your friend in this job to making this clean observability, because then everything has the same shape. That's why we have a standard, many concepts like this. And if you're lazy or if it makes sense, the OpenTelemetry collector can help you a lot. So that's everything I wanted to say here. Sorry if I went a lot of time. I think more or less we're fine. But this is what I wanted to share today. So thanks for coming.
Awesome. Thank you so much, Jose. That was so informative. I love learning about manual instrumentation because you know how easy zero code is, but I really like everything that you broke down for us. So that was awesome.
Thank you.
Yeah.
Yeah. So Victoria, if you want to go ahead, go for the Q&A. I will go away, and you guys can do that.
Yeah. So it's time for Q&A. But before I do that, I just wanted to say I had braced myself for a very technical talk, but the presentation was really fun and engaging, and I found myself grinning throughout. and the GIFs were fun. Were just fun. And I loved the dog illustration to explain the importance of traces. That was really on point. So yeah, just wanted to say that.
Thank you very much. Thank you.
We do have one question from VJ Koneru. I hope I'm pronouncing your name right. So he's asking if you're applying tail sampling and the observability vendor is generating span metrics, will that be accurate value?
That's a great question. To the best of my knowledge, I hope I am not telling anything wrong, but people can actually correct me if so. So how the OpenTelemetry collector works, and it all, of course, depends on which kind of architecture you use. Some people use the collectors or architecture of collectors that maybe they are chained, so there are many nuances to take into account. But what I want to say here is that the OpenTelemetry collector works in stages. So what I was showing is you will define a connector, right? So before your traces go into this connector, if they don't get sampled, then you will have all the information you need. So I am pretty sure you can do this without losing your data or losing this generation of metrics.
Thank you. I hope that answers your question, Luigi. If not, you can always you can always reach out to Jose on LinkedIn, on OTel Slack, CNCF Slack. Yeah, that's all the questions we have.
Mm-hmm.
Cool.
Yeah.
Cool.
Mm-hmm.
Awesome. Well, as we close out here, I just want to say thank you to Jose again. You killed that, and it was awesome. And thank you so much to Victoria for co-hosting. Oh, actually, we might have another question. I might have spoken too soon.
Ooh. From
Okay.
from YouTube. One point that I often hear it raises questions. One point that I often hear, oh, I'm not reading that right, is about manually instrumenting async communication such as messaging and multi-threaded codes and how context should or must be propagated. It's more like a comment.
Yeah,
Okay.
yeah. It's this is also a great or a recurrent question. Myself, I have to say, I've been mostly using it for HTTP. I just read and understood some parts of async message bus communication. However, several things here, right? Because I think there are several things here together. So first of all, we have semantic conventions. So the semantic conventions, you will be using them for this sort of messaging. So that part is covered, right? Then there is a common problem, I know, from always trying to keep the same trace as parent, right? So at some point you need to break it. So this is really important to see how, and this goes with manual instrumentation. Like you need to decide, like now my trace is broken, or I finish my trace here and I create a link. Right? This is really a decision. It depends really on how your provider or your UI is going to treat it in the end. What I would recommend always, in terms of tips, because you're asking on that, right? Is to fine tune yourself. I know maybe this is not the answer, like there's no magic bullet, unfortunately, but to have a volume, let's say, a number of spans within your trace that is good enough for you, and then break it as soon as you can, just to avoid, because then your tracing, your backend will have problems retrieving all those spans. We have seen thousands of spans and thousands of spans in the same trace, and that can kill any production system, right? So there is no silver bullet, but at some point you need to break it and say, okay, now this is another trace. So it's really on how your architecture goes. But yeah, that would be my recommendation.
Awesome. So next question. Is the processor able to filter traces as well?
Aha. So I understand we are talking about the processor that I showed in the slides, in the manual instrumentation. I don't recall. For the life of me, I don't recall for the traces processor in the SDK. You can totally do it in the collector. That's for sure. I just don't recall how would you do that in the manual instrumentation processor. I would need to check the documentation on how is that created. But if you cannot do this here, you will be able to do it later in the collector.
All right. So that answers that question. One more question from George or Horde. How do you handle cardinality explosion when span metrics generates a series per span attribute combination? Any relabeling
Mhm.
recommendation?
Mhm. Mhm. Unfortunately, this is always well. How do I handle it? I pray. No, just kidding. Uh, uh, um, unfortunately, as I say, it really depends on the case. So you should you are on the right track there with relabeling every. So, but the explosion, like in Prometheus or time series database systems as VictoriaMetrics, there is this problem with cardinality explosion, also with logs actually. Uh, the point with this cardinality explosion is that if you will add one new value that has new labels, it will generate a lot of metrics out of the blue because there's a recalculation needed there, right? So it really depends on the case, as usually, but as usual. But in the collector, you can do these strategies to avoid them reaching your um, um, your backend, right? So it's a good point to do it here, and it's not in the, let's say, because we're talking about traces, right? And how we instrument them. So it's not in the code, it's not in the backend. I will do it in the collector.
Okay. So the key point. Okay, we can only take one more question, and maybe Jose will go respond to the rest of the questions in on LinkedIn and on YouTube. So the next question is asking any recommendations on how to instrument web sockets.
So if I would need, so recommend how I would approach this. First, language that you are doing this. Check your language. Is there a library for you in the OpenTelemetry ecosystem? Then check for semantic conventions. If there is no, raise your hand, make noise, because I've seen many semantic conventions appearing all the time. I like for everything there will be, and that's great. So I would check all of these stages in steps, and always take into account this while instrumenting these concepts that I said. Right, you have the API, you have the SDK. So don't pollute your code with the API part. The SDK, keep it for later. If we are talking about WebSockets and we are talking about C, pure C, not C++, I am afraid you don't have a library for you. So then that can be tricky, right? But if you really want to do this, then I would say read the standard and stand on your own generating this from the standard. And if you are doing it in C, maybe C++ can be a good help for you to start start with that.
Okay. Thank you. Thank you very much. So that's all the questions we can take. Sophia, over to you.
Yes, awesome. Once again, thank you so much, Victoria. Thank you so much, Jose, and thank you to our man in the back, Heinrich. He's been coordinating all of these amazing transitions, and he's been very nice, very good. So yeah, just to close out, just a couple of housekeeping notes for the end user SIG. For KubeCon, we're looking for people to join us for Humans of OTel. So reach out to the end user SIG's Slack channel within the CNCF community. And contact us if you feel like if you're going to KubeCon North America and if you feel like being interviewed, we would love to interview you. Um, Another thing is this forum is a great way to try out your talk for an open telemetry conference or to just get feedback on it and really like build it out. So please hit us up at the end user SIG, um, and we would love to hear from you. One more thing is that we would love to also see people from APAC, the region, APAC. So we would love to see people from that region, and we would love to have you talk about anything OpenTelemetry related, anything cool you learned. The community always wants to hear it. Thank you so much, everybody, and have a great day. Bye.
Bye.
Mhm.